Welcome to the AI Show by Brainwave Audio, bringing you the latest in artificial intelligence and machine learning. Hosts Liam Foster and Ava Monroe dive into cutting-edge research,
Groundbreaking innovations and ethical discussions.
making complex topics accessible.
Tune in weekly for expert analysis
Interview.
and insights that reveal how AI is shaping our world.
Discover the future with us.
For today.
Welcome to the Deep Dive. Today we're tackling something pretty mind-boggling. The world of hybrid cloud platforms and microservices.
Sounds complicated.
It is, but imagine this. Okay,
Mhm.
you're a business, right? And you've got to juggle all these resources between your own private cloud and those, massive public clouds, AWS, Azure, those guys.
Right.
And you have to make sure that all of your applications, all the microservices they're made up of, are all running smoothly, efficiently, and without completely, draining your budget.
Yeah, that's a challenge. A lot of companies face that every day.
For sure. And that's where AI can actually step in.
Right.
And so this paper, AI-driven resource allocation framework for microservices in hybrid cloud platforms.
Yeah.
It lays out how AI can kind of orchestrate this whole complex dance of resources.
It's a really interesting paper, yeah.
Yeah, so what's in it for our listeners? Why should they care about AI-driven resource allocation?
That's a great question.
Yeah.
Well, by the end of this deep dive, you'll understand how these cutting-edge AI techniques are being used. Okay.
To optimize these systems, and how these strategies, they can actually lead to some major cost savings.
Major.
Yeah, we're talking about a potential reduction of like 30 to 40%.
Wow. Okay.
And efficiency, we could see that boosted by, 20 to 30%.
That's significant.
And we'll even touch on like the real world tools and technologies that bring this all to life.
Cool. So that's a game changer. Imagine slashing your cloud costs by up to 40%. That's the power of, this AI-driven resource allocation. Think of all the resources you could free up, all the new projects you could take on.
Yeah, the possibilities.
Yeah. But before we get too far ahead of ourselves, let's set the stage. What are hybrid cloud platforms and microservices? Like, why are they so popular these days?
Well, hybrid cloud platforms, they kind of combine the best of both worlds.
Okay.
You get the security and control of a private cloud,
Okay.
but with the scalability and the flexibility of, a public cloud.
I see. And then you've got microservices architecture. This breaks down applications into these smaller, independent services.
Right.
And they can be developed and deployed and scaled individually, which offers a lot of agility,
Okay.
resilience, and the ability to, adapt quickly to all these changing demands that are happening.
That makes sense.
Yeah.
But I imagine this also adds a whole other layer of complexity when it comes to, actually managing those resources.
Oh, absolutely.
Yeah.
You've got these dynamic workloads. You've got complex interdependencies between all these different services. And you have to make these resource allocation decisions in real time.
So you can't just set it and forget it.
No.
Mm.
The traditional methods, things like static provisioning and manual scaling, they just can't keep up.
I see. So static provisioning is like trying to, predict exactly how much food you'll need for a party, months in advance. You might end up with way too much or not nearly enough.
Exactly.
And manual scaling's like, I don't know, like trying to adjust the oven temperature every few minutes while you're baking.
Yeah.
It's just way too much effort, and you might still end up burning the cake.
You probably will.
Yeah, you'll probably burn the cake.
Static provisioning, you'll end up with wasted resources.
Yeah.
And then manual scaling, it's just too slow and reactive for today's, really dynamic applications.
Right. Okay. So this is where our AI hero steps in to save the day, right?
Yes.
So how can AI actually help with this resource allocation dilemma?
AI can analyze tons of historical data, things like, resource usage logs, workload profiles, and even past anomalies.
Anomalies.
Yeah.
Okay.
So, those unexpected moments where something went wrong. And this allows AI to kind of predict what future resource demand will be.
Oh, wow.
And then optimize allocation in real time, making sure the right amount of resources are available at the right time.
So it's like having a personal assistant,
Mm.
One who knows exactly how much cloud power you're going to need at any given moment, making sure you're not overspending or underperforming.
Exactly.
That sounds really promising. But I mean, aren't there different approaches to AI? How does it actually work in practice?
There are. So this paper focuses on two main approaches. You've got supervised learning and reinforcement learning.
Okay, so break those down for me. What's supervised learning?
So in supervised learning, the AI, it's trained on all that past data, kind of like studying for a test.
Okay.
And it learns to recognize patterns and make these predictions about future resource needs based on those patterns.
So if we trained a supervised learning model on like past CPU usage data,
Yeah.
it could like predict when we'll need more processing power in the future.
Exactly. Algorithms like linear regression, random forests, and neural networks all fall under this category.
Okay, and what about reinforcement learning?
So reinforcement learning, that's a bit more adventurous.
Okay.
It's like giving the AI a set of tools and letting it kind of experiment to find the best way to achieve a goal.
So it learns through trial and error.
Yeah, getting rewards for making, decisions that improve system performance and reduce costs.
Oh, interesting. So it's more like, I don't know, letting the AI try different recipes until it finds the perfect one. But that sounds a bit more hands-off, but maybe also potentially riskier.
It does require a careful setup. You've got to monitor it, but the potential rewards can be huge. Think of it this way. The AI could experiment with different, VM instance types in the public cloud
Okay.
to find the most cost-effective option for a given workload. It wouldn't need explicit instructions on what to choose. It would just learn by doing.
That's really cool. So it's constantly optimizing based on real-world feedback. So the AI is essentially like learning on the job.
Exactly.
Wow.
One popular approach in reinforcement learning is called Q learning.
Q learning.
Yeah. The AI gets rewarded for making good decisions, penalized for making bad ones. So this way, it gradually learns the optimal strategy for allocating those resources.
So it's like training a dog with treats and timeouts, but for AI and cloud resource.
Yeah.
Exactly. I like that. So how does all of this come together in a practical framework? This paper mentions a 4-layer framework, right?
It does, yeah.
Okay, so let's unpack that. What's the first layer?
The first layer is the data collection layer.
Okay, so what's happening in this data collection layer? Is this where the AI kind of gathers all the information it needs to make those intelligent decisions?
Precisely. It's like the AI is building its library of knowledge. So this layer gathers data from all these various sources, like resource usage logs, workload profiles, environmental data, and even records of past anomalies.
Oh, right.
Remember those?
Yeah.
Those unexpected moments where something went wrong. This diverse data set is really crucial for training those AI models.
The AI is gathering all this data, almost like, a detective collecting clues.
Yeah.
But what happens next? How does it actually use this information to make real decisions?
That's where the second layer comes in, the AI model layer. This is where the magic happens. Think of it as the AI's brain, processing all that data and making those critical resource allocation decisions. And it's got two main components. You've got the prediction module and you have the optimization module.
So let's break those down. The prediction module, what does that do?
Well, the prediction module, just like it sounds, it's all about forecasting future resource demands. It uses those supervised learning algorithms we were talking about earlier, like linear regression or neural networks,
Okay.
to analyze the historical data and predict what resources are going to be needed and when. For example, it might analyze past CPU usage patterns to predict when you're going to need more processing power in the future.
So it's like having a crystal ball that can tell you how much cloud capacity you'll need next week, next month, or even way further down the line.
Exactly. It's pretty amazing what it can do.
That's impressive. But predicting demand is only half the battle, right? You also need to figure out how to actually allocate those resources efficiently.
You're absolutely right. And that's where that optimization module comes in. This module uses reinforcement learning to make those real-time decisions about resource allocation.
Okay.
It's constantly experimenting, learning, adapting to find the very best way to distribute resources across that hybrid cloud environment. Remember we talked about Q learning?
Yeah.
This is really where it shines.
Right. So the AI gets rewarded for making good decisions and penalized for the bad ones. But can you give me a more concrete example of how this might work in practice?
Sure. So imagine you have a microservice that experiences these occasional traffic spikes,
Right.
maybe during a flash sale or a product launch, something like that.
Yeah.
Well, the optimization module, it could actually experiment with different strategies. It might try keeping that service in the private cloud and just scale up resources there.
Okay.
Or it might try migrating the service to the public cloud where there's, typically more capacity available. By analyzing the outcomes, the costs, the performance, the availability, the AI learns which strategy works best in these different situations.
That's a really elegant solution. That's just it's impressive how the AI can just continuously adapt and optimize based on like real-world feedback. So the AI has made its prediction. It's decided on the best allocation strategy. What happens next? Like, how are those decisions actually implemented?
Well, that's where the third layer comes in. It's called the decision layer.
The decision layer.
This layer acts like the conductor, you know? It translates the AI's decisions into like concrete actions within that hybrid cloud environment. It connects to the cloud orchestration tools like Kubernetes, which we talked about earlier,
Yeah, Kubernetes.
to execute those decisions.
Right. So Kubernetes is acting like an intelligent conductor, making sure all those microservices are playing together smoothly, scaling them up or down as needed, and handling all the complex logistics of, managing a system like this, a distributed system.
Exactly.
Yeah.
That's a great way to put it.
So the decision layer is essentially the link between like the AI's brain and the tools that actually control the cloud infrastructure.
Precisely. It bridges the gap between the AI's recommendations and the actual execution of those recommendations.
Okay, that makes sense. So we've gathered data, we've trained our AI models, we've made those real-time allocation decisions. Are we done? Is that the end of the story?
Not quite. We have one more very important layer, the feedback layer. This layer ensures the AI keeps learning and improving over time.
Okay,
It's like the after-action report.
I see.
How well did the system perform based on what the AI decided?
So it's constantly monitoring and evaluating the outcomes, always looking for ways to do it even better the next time around.
Precisely. The feedback layer gathers data on those key metrics like cost, latency, resource utilization, and, any errors or anomalies that occurred. And then that data is fed back into the AI model layer so that the models can refine their predictions and optimize their strategies even further.
So that's a critical piece. Without that feedback loop, the AI would just be like stuck, unable to adapt to changing conditions or learn from any mistakes.
Exactly. It's a cycle of continuous improvement. The AI is always striving to become a better conductor.
Yeah.
Orchestrating those cloud resources more efficiently and effectively with each iteration.
So we have this really sophisticated 4-layer framework that empowers AI to make smart resource allocation decisions.
Right.
But how well does it actually work in practice? What kind of results do the researchers actually see?
Well, this is where things get exciting. The researchers, they conducted a series of simulations to evaluate the performance of this AI-driven framework compared to those traditional approaches.
Okay.
And the results were, well, to say the least, they were pretty impressive.
Give us the highlights. What kind of improvements did they see with AI at the helm?
Across the board, the AI-driven approach it outperformed traditional methods like manual scaling and rule-based auto-scaling. We're talking about significant cost reductions, improvements in resource utilization, lower latency, and enhanced scalability.
Those are some really bold claims. So let's break those down one by one, starting with cost efficiency. How much money can businesses realistically save using this AI-driven approach?
The simulations showed a potential cost reduction of up to 30–40% compared to traditional methods, and that's because the AI is it's incredibly efficient at allocating resources, making sure you're not overspending on capacity you don't need.
That's a huge difference. Imagine what companies could do with those savings. They could invest in new projects, they could hire more talent, they could just improve their bottom line, right?
Absolutely.
What about resource utilization? How does AI make sure those cloud resources are actually being used effectively?
Right. Instead of letting servers just sit there, idle, racking up costs, but not really contributing anything, the AI can dynamically adjust the resource allocation to match the demand. This makes sure that you're getting the most out of that cloud investment, not wasting those valuable resources.
So the AI is making sure that every instrument in the orchestra is playing its part, contributing to that overall performance instead of just, sitting there collecting dust. What about latency? How did the AI-driven approach affect the, responsiveness of the applications?
Well, by anticipating demand and proactively allocating resources, the AI was able to actually significantly reduce latency. This means faster response times for users, smoother application performance, just a better overall experience.
So the AI is like a mind reader.
Yeah.
It knows what you need before you even ask for it.
Right. It's pretty amazing.
Yeah. I mean, that's so crucial in today's world,
Yeah.
Everything's digital and everything's fast-paced. Every millisecond counts.
For sure.
Okay, so what about scalability?
Right. So the AI's ability to learn and adapt in real time means that it can handle those sudden, unpredictable surges in traffic without breaking a sweat.
Okay.
No more scrambling to add servers manually or worrying about your application, crashing under pressure.
So no matter how big the orchestra gets or how complex the music becomes, the AI conductor can handle it.
Exactly, exactly. A flawless performance every time. The simulations really showed that the AI-driven approach can just gracefully scale those resources up and down as needed, ensuring those applications can handle whatever comes their way. These results really highlight how powerful AI can be in managing these complex hybrid cloud environments.
It sounds like this technology could be like a total game changer for businesses, especially those that are struggling to keep up with the ever-increasing demands of the cloud. But I'm curious, this all sounds very theoretical. How is this AI-driven resource allocation actually implemented in the real world? What are the tools and technologies that, like, make this magic happen?
Yeah, that's a great question. And that's actually what we'll be exploring in the next part of our deep dive.
Right.
We'll get into those real-world tools and platforms that are being used to build these AI-powered systems.
So we know that AI can bring some pretty serious benefits to resource allocation, in these hybrid cloud environments.
Right.
But how does all of this, theoretical wizardry actually translate into, like, real-world applications?
It's all about having the right tools and technologies. And there's like a whole fascinating ecosystem out there that makes this possible. Think of it like building a high-tech orchestra.
Okay.
You need the instruments, the sheet music, a conductor, even the stage itself.
Okay, I like that. So let's break down this AI orchestra. What are the essential components?
Well, first you need the stage, the foundation that everything else is built on. That's where those cloud platforms come in. AWS, Azure, Google Cloud.
Right.
They provide the infrastructure, the raw computing power, the storage, the networking capabilities, all of that stuff that makes hybrid cloud environments even possible.
So these platforms are like the concert halls.
Yeah.
Offering different sizes, different acoustics, different amenities to suit the needs of our AI orchestra.
That's a great way to put it. Each platform has its strengths and specialties, and the choice often comes down to like the specific requirements of the application, cost considerations, existing infrastructure.
So it's like choosing the right concert hall.
Yeah.
Based on the size of the orchestra, the type of music being played, even the audience experience you want to create.
Exactly.
But once you've got your stage, you need a way to manage all those musicians, or in our case, all the microservices, right?
Absolutely. That's where tools like Kubernetes and Docker come in.
Okay.
They're really essential for orchestrating and containerizing all those microservices.
Right.
Making sure they all play together nicely.
Yes. Kubernetes, our intelligent conductor.
Right. It makes sure all those microservices are deployed correctly, scaled up or down as needed, and can handle, all that complex communication and coordination that goes on within a distributed system.
Right, because it is a distributed system.
And then Docker. Docker provides a way to package each microservice into a neat portable container. So that makes it easy to deploy and manage them across those different cloud platforms.
So it's like each musician having their own instrument case that they can easily transport and, set up on any stage.
That's a good way to think about it. It ensures consistency and portability, no matter where that orchestra is performing.
I like that. So we've got the stage, we've got the conductor, the musicians. What about the music itself, the code that brings those microservices to life?
Right. Well, for that, we need programming languages.
Okay.
Python is a favorite. With all its libraries and frameworks, it's really great for AI and those cloud API interactions.
So it's like the sheet music.
Yeah.
Providing those instructions for all the musicians to follow.
Yes, exactly.
Okay, what about other languages like Go or JavaScript? I've heard those are pretty popular for cloud native development.
Oh yeah, they are. Go is really known for its speed and efficiency. Excellent for building, those high performance microservices.
So it's like the conductor's baton.
Yes, precise and efficient, guiding the orchestra with real clarity.
Okay, and what about JavaScript and Node.js?
So JavaScript with Node.js, they're really great in those serverless applications. And, the asynchronous communication between microservices, they're like the rhythm section.
Deeping the beat.
Yeah, making sure the music flows smoothly between all the different parts of the orchestra.
This is starting to sound like a pretty complex orchestra with a lot of moving parts.
Yeah.
What about the brains of the operation, the AI frameworks that actually power those prediction and optimization models that we talked about?
That's where those real powerhouses come in, like TensorFlow and PyTorch. They provide the tools to build, train, and deploy those really sophisticated AI models that can analyze all that data, predict what the resource needs are going to be, and make those really intelligent resource allocation decisions.
So they're like the composers and the music theory experts,
Yeah.
understanding all those nuances of like harmony and rhythm and structure. And they use that knowledge to, create the music that drives our resource allocation.
That's a brilliant analogy.
TensorFlow is more like the grand piano,
Yeah.
right? Capable of like producing a vast range of sounds and emotions. And PyTorch is like a violin, nimble, expressive, allowing for like improvisation and, creative exploration.
I like it. But even with all this complexity, we need a way to make sure our AI orchestra is, performing at its best.
Absolutely. We need some sound engineers and, maybe some music critics to give us some feedback.
Exactly. That's where monitoring and analytics tools come in, like Prometheus and Grafana. They're collecting data on the system's performance. They can visualize those key metrics, and they create dashboards that give you like real-time insights into how everything is running. It's like having a really detailed score.
Okay.
And a team of analysts helping us understand every little nuance of the performance.
So we can see which sections of the orchestra are playing well, which ones might need some fine-tuning, and maybe even identify any potential problems before they, derail the entire performance.
Yeah.
That's critical. But this is like a lot to manage. Are there any tools that help automate some of these processes?
Oh, yeah. You've got tools like Jenkins, GitLab CI/CD, Terraform, Ansible. Those are all essential for automating the building, the testing, the deployment, and the management of these really complex AI-powered systems. They're like, the stage crew, the lighting technicians, the stage managers, making sure that the performance runs smoothly and efficiently.
It sounds like it takes a whole village to bring this, AI-driven resource allocation vision to life.
It really does. It's a real testament to all the innovation that's happening in cloud computing, AI, and software development in general. But the results, as we've seen, are worth all that effort.
This deep dive has been incredible. We've explored like the challenges of resource allocation in these hybrid cloud environments, the potential of AI to address those challenges, and like the whole ecosystem of tools and technologies that make this possible.
And like you said, we've just scratched the surface. This field is evolving so rapidly. The possibilities are they're endless.
Yeah. So what's the key takeaway for our listener today? What should they be like thinking about as they're trying to navigate this complex world of, cloud computing and AI?
I think the most important thing is to, stay curious, stay informed, and don't be afraid to experiment. The tools and technologies are all out there, and the potential benefits are huge.
Imagine a world where like AI is just seamlessly managing all the complexities of cloud computing, letting businesses focus on what they do best, innovating, creating, and delivering value to their customers. It's exciting. We're just at the very beginning of this journey.
Couldn't agree more.
Awesome.
We've actually provided links to the research paper and many of the tools and technologies we've talked about in the show notes. We encourage you to explore further and discover how AI can really transform your own cloud infrastructure.
Thank you for joining us on this deep dive into the world of, AI-driven resource allocation. Until next time, keep exploring, keep innovating, and keep diving deep.